welcome to the America Makes booth here at Rapid Plus TCT. Josh Cramer, Director of Education and Workforce Development here at America Makes. I have Miss Melanie with me from FormAlloy, a tremendous not only member, partner, stakeholder, a great asset to the industry, asset to the America Makes Institute, those kind of things. Welcome, Melanie. Thanks for joining us.
Yeah, thanks so much for having me.
Absolutely. So first and foremost, the elephant in the booth. You brought with us some parts, right?
I did.
So I see over there in the booth, lots of people, lots of exciting stuff going on. Not your first Rapid. You've been here many a times. You're an engaged member with us and across a lot of events. You know, what's new? What's exciting? What are you working on?
Yeah, so we're doing some really exciting things right now with lights out 3D printing. So in order to really have the adoption rate accelerated and go beyond some of the standard applications that you would expect for things like directed energy deposition, like aerospace, you really need to be able to run the parts without any type of operator interaction. And that's one of the parts that I brought here today, where you can run the part. We call it lights out because you turn the lights out for the day and everybody goes home and your machines keep on working and chugging along. So it can be more affordable as you move it into other applications beyond just the very high value aerospace type applications.
That's amazing. I mean, at first I thought maybe this was, they were going to try to keep me quiet and put this over my head. But obviously, so is this a demonstration of the technology? Is that an actual part?
So this is, we took a rocket nozzle geometry and we made some changes to it, but this is a geometry that you can see commonly as a rocket nozzle component. And we made it for ourselves here as a demo part so people can see the nice surface finish that you can get.
Absolutely.
We can talk about build times and just talk about how really with this process, it's a great time to get involved with it if you want to scale your process, build faster, build larger build volumes, still get really nice surface finish and of course mechanical and material properties with it.
Excellent. So, I mean, you mentioned one of the biggest things and barriers to adoption, obviously, right? And that's a passion for you. I've known you for a number of years, and so can you talk through some of those barriers and how you're tackling those? And I mean, obviously, as a company and organization, you're tackling those, how you're tackling them on the personal side as well.
Yeah, I think some of the barriers to entry have been you really need an expert to run a lot of these machines, a PhD or a material scientist, and they have to sort of stand at the machine and watch it and make adjustments as you go. And I think in order to increase the adoption, you have to make these machines run as standard machine tools, so you can use an operator to run them or an operator to run multiple machines. Sure. And we've sort of conquered that by using a lot of in-process monitoring and control, and then data logging, so that way you can validate the quality of the build, which I think is another sort of barrier to adoption, which is, how do we trust these parts? How do we know that they're good? How do we know they're going to perform and they're not going to fail? And again, it's all about the in situ monitoring and control, and then the ability to log all that data and validate that not only individual parameters like your melt pool temperature or your melt pool size are good, but looking holistically at the entire build history, analyzing it, and being able to determine if the part is good quality, and then being able to repeat that as well. So I think it's very important to have access to the data that's coming off the machines, and then being able to use that data to control future builds for repeatability, and then also use that as part of your quality control and validate that what you did is going to meet the requirements.
Yeah, and I think it's tremendous, right? I mean, when we talk about adoption and true adoption and deployment, and identifying those barriers is key. I mean, obviously I'm an educational workforce guy, right? And so you're saying a lot of those buzzwords that we hear too, which is key and critical to a lot of these things. And so, where do you see, in your process, when we talk lights out and facilities and those kind of things, where do you see the biggest need on the workforce side, right? Talk about, all the data coming off of these tools. I mean, one of the things we talk a lot about is, ensuring that we're always educating on the A to Z of the process, right? So that folks see it's not just, oh, I work in additive and everyone knows what that one job is. There's hundreds of job roles and they're very unique and those kind of things. And so I'm hearing things like so much data, is it data analyst specific to additive, and you can start to get creative on some of these job roles. I mean, what are you seeing in there, and maybe what are you forecasting down the road?
Yeah, I think that, like you said, we need a pretty wide range skill mix of workforce in order to support the additive community, because it's not just material scientists, it's not just application engineers, and now that we're at the point where the machine is doing a lot of that hard work and computational analysis for you, you don't necessarily need always the degreed engineers that sort of follow every step. So I think it's really important to have people that are well versed on how things are actually made, and a wide range of both additive and traditional technologies, and then really machine operators that can run the machines, that understand how machines work and how to run G code. And then of course on the data side, you need data analysts that can look at the data and understand what it means and be able to quickly identify if there's any anomalies in that data. And then closing the loop on that in terms of AI and machine learning, which is another discipline. So I think it's a pretty wide range of disciplines that can be everywhere from trade school type of education all the way up to PhD. And I think you need it all, and you need that diversity of training and thought.
Yeah, absolutely. It's one of the things that we work on, right, in our portfolio especially, and I certainly appreciate you literally just volunteering to be an excellent mentor to so many young ladies getting into the field. So I have her live on camera. She can't turn down that volunteer role and those kind of things. I mean, so I'm going to put you on the spot. I mean, what are we going to see from FormAlloy next year at Rapid?
Yeah, so we're going to see a lot more of examples of the lights out 3D printing, and a little bit more on the high volume, general industry side of things as we move from aerospace into some of the lower cost applications and consumer goods. So I expect you'll see a wider range of more general industry and consumer good type of products, and then also all the data that sort of backs that up, that shows we can do a lot of these parts very quickly and efficiently and consistently, and we have all the data to back that up.
That's awesome. Well, Melanie, thank you so much for joining us. Again, tremendous, industry members, partner, just a valued asset to the industry and as a whole as well. So thanks for everything you're doing. It's been awesome to have a moment to sit and talk and chat and meet as well. I really appreciate you stopping by.
Yeah, thank you so much. And thank you so much for all that America Makes does for the community, and especially for the workforce development.
Absolutely.